So there we go.
Yeah, there we go. That's good.
Okay, so my name is Anna Macario, and I'll be giving you a brief summary on O2A. I work at a Computing and Data Center department at Alfred Wegener Institute, okay? Just for background. So I was planning to get into details in what the O2A, I'm having echo. Are you guys also echoing?
No, I'm fine.
You're fine, okay.
I can hear very, very clearly and loudly what you're saying.
Okay, so I'll be telling you about the O2A solutions and then give you a brief outlook on what our plans are all about. So O2A is a modular virtual research infrastructure we designed to support the scientific workflows, essentially to give scientists support to the pipelines in the real world, helping them in the flow of sensor observations to archive. So this is where O2A comes as the acronym. So essentially, we start with the sensor component, which is designed to manage all the metadata on platform and sensors. And once the scientist has done this, we can then give appropriate support for the data acquisition at the field. And then along with our streaming solutions, we have ways of transferring the data from the field into the land archives, and especially near real-time data in support with various types of protocols for data transfer. We then have another component called the dashboard component, which was designed to help scientists in the monitoring of the near real-time data, and especially by having also an alarming functionality, so that when the data reaches a certain, for example, certain limits, minimum or maximum range is over the minimum maximum range, then scientists will get a notification. So it has also this alarming functionality. Then we have our analysis tools, which are supposed to help scientists in viewing the data, of course, also map-based visualization services, but also doing all kinds of statistical analysis. And I'll show you a few instances how we can you would be able to use RStudio or Jupyter Notebook to help you in your statistical analysis. We have, of course, the workspace, which is essentially a bunch of solutions for data storage and processing, and of course long-term preservation. And this is where scientists can put their data and process them. So essentially improving the data quality, going through all the different levels for processing until the data is finally turned over into the repositories. You've all have heard about PANGAEA. So the PANGAEA is obviously official repository. It's also the one that we are recommending in the framework Mosaic. And then when all this is, when you adopt those solutions, one of the nice side effects is that we will be able to disseminate all those different types of information in what we call the data portal, which is an essential one-stop shop framework for gluing all these different pieces of information together under one umbrella. And this data portal is also housing all kinds of interoperability services that we are offering. So if we start with this, so with one platform here, you're seeing an ROV, a remote operated vehicle that is going under ice. It's called the Beast, and essentially what we want inside sensor AVI.AVID is to collect all kinds of information relevant for this platform, which will help in the future when you archive the data. So it's to improve the reuse of this data once you archived in PANGAEA. So essentially, it's about describing this information, not only this platform, not only giving a description of what it can do, but also entering like the contact, different roles of the people. When was this platform deployed? What kind of resources, kind of documents are important for this platform, like calibration certificates or fact sheets and so on. What are the sub-devices mounted in this platform, and what parameters are actually being acquired and at sea or under ice? So this is what we consider as the whole realm of metadata. So if we go now, so going to specifically to the sensor of AED, to our information system, you will see that here we can on the upper part of this projection, you see different tabs, and if you go to sub-devices, for example, you will see sub-devices here. You will see that a list of all the sub-devices associated with this platform, and if you click specifically on the glider, on the CTD, you will see the parameters that are being acquired by this, or the variables that are being collected by this particular CTD. So this is just to give an example. As I said, you have on the top you have this registry cards or tabs, and if you look under overview, and this is the case of a buoy, an ice tether profiler ITB 93, you will see first of all that there is description of this buoy, but mostly important, you can assign this buoy to a particular collection. In this case, only for the sake of demonstration, I added the collection mosaic. And and what is also I wanted to point out in this slide is that once you set up a platform, you will be getting a PID, a persistent identifier, in the form of a handle. This is what you see in this block here. So whenever you create a platform and you enter an action, you enter a calibration action or a commission or deployment or mount action, you will automatically get a PID. And as you can see on this light blue box, this PID comes along also with citation. Okay, so the added value for entering your metadata in sensor of AEDA is that you would have be able to find, of course, you have an organized information system for all the information on this platform and all the sub-devices. You can keep track of all the events, of all the actions that you did to this platform. And the nice thing is you will get a citation and a PID, which you can then use in your publications or use in the other components, which I'll be showing in a few minutes. So this is also very important for you. So going back just 1 second, in this case we have a particular deployment that was done for the ITP 93. The deployment was you can see here, it was done for the cruise PS 94, and what is nice is that you can then relate this event to a data set in PANGAEA. So in this case, we are showing a data set. Going back 1 slide, and this data set is for the automated underwater vehicle PAL. And what is interesting is that particular vehicle, this particular AOV, was deployed in one event. It was on board of the Miriam, of the research vessel Miriam, and this event is here in red. So, and you can see that the handle pointing to the sensor, to the sensor page, which this AUV is described, is also connected to PANGAEA. So this is the way that you close the circle. So you describe your once you describe your platform and respective sub-devices in Sensor AVD, you will be able then to link this to PANGAEA. And you probably know this, but once you put a data set in PANGAEA, you can also relate to a publication article, and this is what we place our publications in the repository EPIC. You probably have other repositories at your institute, but it doesn't matter. So it is always able, once you have your data set in PANGAEA, you can link it to the publisher DOI, and you can also link to the sensor. And finally, the description of this platform would then show up in our data portal. And this is how you see here in the last block is the landing page for the AUV in our data portal. So as I don't know, I'm not sure you can see this, but we have all the devices being listed in gray boxes at the very end. So okay, so we go into another slide. One of the things that probably for you in the ICE group will probably be interesting is the cloning functionality. So essentially, once we define a standard buoy or a standard mooring, you are able to use to create multiple buoys, so like in a bulk creation fashion, by simply clicking this clone button that we have there, what I'm showing here in red. So this will help you for the batch ingest of let's say 100 buoys at a time. So don't worry if you think, oh my God, I have a lot of buoys, a lot of moorings. Yeah, don't worry about this, because once you get to define ones, you'll be able to create a clone. And this example here is for the FEVI 36. You can see that you can select exactly what you are cloning. You know, I don't want to clone the actions, but I want to clone all the documents, all the resources, all the properties, the parameters, and so on. And then you can specify the number of clones you want. So you can have in one shot, you can create like 20 platforms identical to this FEVI 36. Okay. I understand you all have worked in Excel list, trying to in which you made a rough list of the platforms you're planning to deploy in Mosaic next year. So this is the Excel list is a good start for planning, especially the storage resources for the data management plan. So the next step is then would then be to assign a couple of editors for your team, a couple of people who would then enter this information in Sensor, and Antonia Imat would then help you with this. She'll be in contact with you via email to pin down precisely what the next steps are. So once you have entered the metadata for your platforms in Sensor AVD, you will be able to find the data very easily. You can, for example, we have a very powerful search functionality, so you can search for example, all the microcats that you entered, and you can see here you can search for whatever collections you are interested in. So one of the possibilities, for example, is that we create for Mosaic, we create several collections. I understand you have 6 data teams, so for every team a collection, so you can make lists of all the platforms, devices, for example, for Mosaic Ice, or for Mosaic, I don't know, Atmosphere, and so on. So this is very flexible. We have then to discuss how we would like to create the collections, whether one big Mosaic collections or separate by teams, and then you'll be able to search this as you wish. Okay, so summarizing the steps that you will have to take is, first you will have to request an account to censor@avei.de, essentially sending us your name, email, and affiliation. You need to, you would then start creating a platform. Please make sure that you assign the appropriate type of platform. If it is a buoy, there is a type called buoy. If it's a mooring, there's a type called mooring. If there is a type, if your platform has to do with a type that you don't find in this list, simply contact us at censor@avei.de and we will insert it. Please make sure that when you are creating your platform, you keep the stuff under workflow status construction, and make sure that you assign the collection Mosaic. This is all under this overview tab which I showed in the previous slides. Yeah, fill out all the mandatory fields, make sure you enter all the subdevices, all the instruments mounted in your platform, of course, and the respective parameters. This is going to be important later on for the data transfer aspect. I will show in a few minutes. Of course, please do deposit all the relevant documents you may have or images you may have of this platform. The other point that will also become important for us is that under the contact tab, please make sure that you fill out the role owner, because this is the way that we will have then to separate, to tag the ownership of the different platforms to different institutes. Okay, so this is really very important. And as I said earlier, use the clone function to create identical platforms, for example, this batch mode, if it is necessary in your case. Once you think you're done, you can change the workflow status to public, so does your record go live. Make sure you enter the dates for once you are on the field, of course, when this platform has been commissioned, deployed, or mounted, and this is all under the Action tab. And then this way your platform will get a PID, a handle, and will be site enabled. Before going to the next component, the dashboard, I'd like to point out that we have created several tutorials, and this will help you to insert, to create the platforms, and we are also planning to have a very user-friendly video with the basic of all the sensor concepts, and this will happen more or less like towards the end of November. And as I said earlier, Antonia will be there to give you support in the creation of the metadata. So now we go to the next component, the dashboard. In the dashboard, we can essentially display 2D graphs of all kinds of parameters you may choose. In this example I'm showing here, I have using widgets of type map. So we have images, we have map, text, or value monitor, and I used the chart wizard to create a graph on the air temperature on board of Polarstern, and this is the chlorophyll A value from the ferry box platform on board of Heinke. So it's very useful, and the nice thing about those dashboards is that they are connected with the sensor AVI, so that if you define in sensor in your properties tab that you have a minimum and maximum range for temperature, I don't know, between -20 and +5. So you would then, whenever this range is outside this, whenever the value is outside this range, you would get an email notification, for example. Or whenever this sensor starts putting out a lot of errors, you would get an email notification. So this is the way to really monitor what's going on with the sensor on the field, and of course producing nice graphs. Those graphs, you can do all kinds of stuff. You can create statistics. You can set up graphs, one on top of the other, and then zoom in and zoom out. So it's very flexible. Once you get a password an account to Sensor AVID, you can use the same account to build your own dashboard with the parameters that you may wish you define. So now going into explaining a little bit the status of the analysis in the workspace component we have built so far. So this is an example for an RStudio template, and essentially what we are showing here is how you can easily connect to the near real-time database. We have here on land, and we will have one also on board. And for example, in this case, we are plotting the temperature values from the ferry box mounted on polystyrene. Okay, so this is the kind of stuff you'll be able to do on board very easily. So essentially allows users to run R, which is a very powerful language for statistical analysis in a very user-friendly environment. And we are planning to have virtual machines on board where RStudio installed. So some of you may also have heard about the Jupyter Notebook. The Jupyter Notebook is essentially a server-client application which has a very interactive command line type of window that helps users to run the code and access variables or call up the data analysis packages and view plots and so on. So here's again a similar example for understand temperature values out of the ferry box, and so it's essentially very powerful for sharing the code, for doing little tweaks and rerunning the code, and you'll be able to see this new execution in the document you're reading. It would allow you to see instantaneously whether the changes you're doing are improving the algorithm or not. So it is very helpful. And some may also know that notebooks are currently even being published as supplement for Elsevier publication. So again, we're going to have a Jupyter Notebook, at least one VM of a Jupyter Notebook running on board, for the ones of you who might be interested in this kind of analysis. So so going now to a little bit the end of the pipeline. So once you have collected the data, you are probably going to create beautiful data products, and of course one of them would be GIS projects, GIS data products. And as you can see with this example, I'm trying to show that, you know, we would hope that at the very end of Mosaic we can have a very comprehensive quality controlled data from various variables. The one that we are showing here was compiled by Axel Behrendt, and he did this for the Arctic, and specifically what you're seeing at this moment is in this slide is temperature at 10 meters depth, yeah, it's so this is the kind of data products you may want to consider producing. And as I said, once you have the data and in our system, it would be much easier to use this type of GIS visualization facilities we offer. So yeah, not only we would offer you support for map visualization of the data and data products you're producing, but it is probably important for you to know that we offer also very standard data products like base maps for bathymetry or satellite-based chlorophyll A or sea ice from globe color data products and so on. There's also a lot of Copernicus satellite products which we have also as services here. So it is going to be this could be really helpful for you to overlay stuff with the layers you have. Again, PANGAEA DE, I think it's well known. You will get it's the repository of choice for Elsevier. It's a great repository for not only for data archive, or not only in terms of data archiving, but also for the fact that we are minting data DOI, which means that your data set will be citable. And you can link your data set later on to Elsevier as a supplement, or as I showed in an earlier slide, you can link the data directly to the platform description in Sensor. So this is the example for the submission form in PANGAEA, and maybe just saying that we are planning to organize more detailed information on how to submit your data into PANGAEA and how to get the data out of PANGAEA later on. At this point, it's also important to mention that it's also possible to archive raw data sets in PANGAEA. Please get in contact with the data scientists in your team if you're interested in this kind of archival. So, and now we're getting close to the last component, which is the data portal. It's essentially, as I said, a one-stop shop framework for finding all kinds of information which are relevant for scientists. Now going very specific to what I think it's important for you in the ICE group. So in this slide, I'm showing you, if you go into the tab platforms, you will see that we can filter, there is a facet search, you can filter the device types. In this case, you can filter the platform. In this case, I filtered to restricted to buoys, and I selected the maps, the map view. So those are the positions of all the buoys we currently have at Sensor AVI. Okay, and so if you click in one of them, you get a pop-up window, and as you can see, you get here a little description of the buoy, and this is coming everything from Sensor AVI, along with links to how to go straight to the sensor description in Sensor AVI, or get the data for this particular buoy. So we have for every platform, we have a landing page, so a splash page describing the platform, or listing all the resources which you have placed in Sensor, and of course listing all the sub-devices attached to this buoy. If you go to the expeditions tab, you will see on the left-hand side facets, and you are then able to filter the results of your query according to different parameters. In this case, I said I'm interested only in having the moorings and having the expeditions in which the moorings were deployed, and those are the listing for the expeditions. Okay, and on the right-hand side, you can go straight to the stations or to the station list, or see the track line of a particular Polarstern leg or Heinke leg, and go straight to the data publications or reports. Okay, if you go to the Data tab, again, we have a very powerful search, and here you can filter the search. I want to see only the data, or only the publications, or even the GIS layers. What are the GIS layers for related to Polarstern and ARC 27.3? Okay. We also offer collections in the Collections tab. In this case, I'm showing you the FRAM collection. Here we can display several layers, and this is an overlay of chlorophyll A together with the Fezon seawater temperature model, and in blue you see the platforms. In this case, are buoys. Okay, so we can also have collection. In this collection, we also offer links going straight to the simulations, videos, and audios. So we're getting to the end. So what's really important to point out is O2A is FAIR compliant, which means all the information is findable, accessible, interoperable, and reusable. And this is really very important for part of the good scientific practices. So what are we planning the next? So before I get into more details, it's important that you all get an ORCID if you haven't done yet, because if you authenticate with your ORCID to the O2A components, we would then be able to extract automatically your affiliation. This is going to be important for you, and you won't have to do this manually later on once in your user input information form. Okay, we are also planning, let me put this way, we have started developing a generic driver solution for transferring the data from the view to the NRT database. It's what we call our ingest solution, and it will be part of the sensor AVIDE. So essentially, you will have to specify the transfer protocol. In this case, IMAP. So type email, and there is a script that, for example, would then read this email, whatever parameter that you then specify here, and this script would then change this email to the format that is compatible with our database, so that we can import it in the database. But it could also, for example, change to another format, or it could read other formats like NetCDF and so on. So this is very flexible. We will have to develop the drivers on a one-to-one basis, but essentially we are trying to come up with a couple of generic solutions first, and we're going to try to learn from your use cases to see what would work the best for you. You will be contacted later on this part. As I said earlier, we're trying to link ORCID to all our O2A solutions. We are in the process of consolidating storage, processing, analysis solutions for Mosaic on board of Polarstern, and there are also initiatives towards an integrative management concept for the physical samples, including the international GEOS sample number at a later point. Yeah. And so here is a quick overview on our team, and people will be helping you directly are Antonia and PANGAEA. So thank you for your attention, and you can